Welcome back. We just saw how linear regression can find the best line to predict a number. But what if we want to predict a category? For that, we turn to one of the most important algorithms in machine learning, logistic regression. The problem we face is simple. Linear regression outputs a number that can range from negative infinity to positive infinity. That's not very useful if we want a clear yes or no answer to a question like, will this customer buy our product? Using a straight line for a categorical problem is using the wrong tool for the job. The brilliant solution is to take the output of a standard linear equation and squash it. We do this by feeding the result through a special S-shaped function called the sigmoid, or logistic, function. This function takes any number, no matter how large or small, and transforms it into a value neatly between 0 and 1. This output between 0 and 1 is incredibly useful, because we can treat it as a probability. So instead of predicting an arbitrary number, the model now outputs the probability of the answer being yes. We can then set a simple threshold, usually 50%, to make our final decision. If the probability is higher than 50%, we predict yes, otherwise, we predict no. Now, here's a very common point of confusion you need to watch out for. Even though it has regression right in its name, logistic regression is a classification algorithm. It's one of the most popular and powerful tools for predicting categories. It gets its name simply because it uses the same linear equation as its engine, before squashing the output. Because it's fast, reliable, and easy to interpret, logistic regression is a workhorse in the industry. It's used for everything from spam detection in your email and fraudulent transaction detection at your bank, to predicting whether a patient has a certain medical condition based on their test results. And with that, you understand your first, and arguably most important, classification algorithm. You see how a simple trick, the sigmoid function, can transform a line into a probability, allowing us to predict categories. But decisions in the real world aren't always so linear. In our next lesson, we'll explore a completely different, and very intuitive, way of making predictions with decision trees.